Now the fore and aft crosshair on target. Well, where have you been? You'd have quite a time synchronizing on a course like that, wouldn't you? All right, go back to where you started. Now look at the line in the flooring. That was your sighting line when you started. Go straight to the target. I know, when you're up in the air, there aren't any nice, convenient lines drawn on the ground to help you. Your bomb sight, though, gives you the equivalent of them. Remember how the sight's made in two parts? Underneath, there's the stabilizer. And in that, there's another gyro, only it has a horizontal axis. Above that is your sight. The stabilizer is fixed in the longitudinal axis of the airplane. But you can keep turning the sight so that it's always pointing at the target. But the sight is also connected to the stabilizer by rods. By these, the gyro controls the position of the sight so that no matter how much the airplane yaws, the sight will always point in the same direction. But, and this is what's important here, the gyro gives you a constant reference in azimuth. Let's see how it works. Suppose you're coming onto the course from there. You haven't got your gyro clutched in, so you simply point the sight at the target. You have the target under the fore and aft crosshair, so you clutch in the gyro. Now go ahead, only don't forget the wind. No. Remember, your gyro is holding your telescope in the same direction you started with. Parallel with the floor lines. See what's happening? You're drifting downwind. Exaggerated here, of course, but that's what you'll see through the telescope at the bomb sight. The target moving away from the vertical crosshair. So what do you do about it? That's right. You turn the sight back toward the target. And by doing that, you're automatically telling the pilot to change the heading of the plane. That target's still drifting off. That's because you turned the sight and the airplane the same amount. The only way you can kill drift is turn the airplane farther than you turn the sight. Try it. Never mind keeping that telescope on the target. Get your drift killed first. There you are. Hold it. Don't change the angle of that telescope. Just lower it the way it is. See the angle it makes with your heading line? That's the same, isn't it, as the angle with the reference line which the gyro has been holding all this time. Well, that's your drift angle. The angle you must set up to get on a collision course over the target. All right, suppose you're in that plane again. And imagine there's a plane just below you on a bombing run. Okay, here's what it would look like. There it is, and you can see its ground track. All right? The bombardier's picked up the target, and he's clutched in his stabilizer. Now, suppose he uses his turn knob to correct for drift. That means he turns the sight and the airplane equal amounts. Well, that didn't get him anywhere. You can see he's still drifting. So now he turns the plane faster than he turns the sight, until finally his sight line and his ground track coincide. In other words, he's established the correct drift angle, and he's on a path parallel to the collision course. Are you worried about not being on target, even though you killed drift? Well, on a real run, you wouldn't have gotten so far off. All right. Once you've killed your drift, how do you get on the target again? Well, simply turn the sight and plane equally. That way you won't affect your drift angle. Hey, you dropped that bomb a long time ago. Now what? You don't miss anything, do you? Not even cross trail. But you're right. That bomb will fall trail distance behind the plane on the line it's heading on. So what do you do about it? Yes, that's the course you should have been on. Upwind of the target and parallel to your collision course. But how are you going to get on it? You can't just guess at the cross-trail distance. There's a formula for it. Cross-trail equals trail times the sine of the drift angle. Well, you don't have to worry about the mathematics. The sight takes care of that for you. Look. There's the plane flying over the target on a collision course. You can see where the bomb drops. Cross-trail distance downwind. And here's another plane, coming the same way. Only when it starts to set up its drift angle, it begins to head further upwind. Until finally it's on a course parallel to the collision course, but cross-trail distance upwind. How was that done? Let's see you try it. No, that's not it. Steering for someplace upwind won't do the trick. In the first place, that would throw off your drift angle. Besides, how would you know where to head for? Hold up that telescope again. Now move it as if you were adjusting it for range. All right, now for direction. Now notice one thing. As long as you kept that bar horizontal, that meant your line of sight was always moving in a vertical plane. Well, suppose you tilted the telescope to the side. That's the way. And that's exactly what the bombsight does. It automatically tilts the telescope so that to stay on the target, you have to move cross-trail distance upwind. All right? Now try another run. Now change your heading. Only this time, tilt your telescope as you do it. You've got your drift killed? Now get back on target. Okay, bombs away. See how it works? That tilt in the telescope brought you just the right distance upwind. And yet your drift angle wasn't affected. Well, that's about it, mister. Think you've got it all? Range problem, setting up range angle and releasing when the sighting angle matches it, killing drift by setting up a drift angle, and tilting the optics to allow for cross trail. The sight does that one for you. Looks like they're getting ready for a class in here. Well, you're jumping the gun a little bit there, but let's look. What's the matter? Doesn't it seem so simple now? Well, don't let it worry you. Sure, you'll have to learn what all those knobs and switches are for. But it's still the same question of when to drop your bombs and how to get on course. Once you've started on the run, all you need to use are these two sets of knobs. The course knobs and the rate knobs. That's right. That's what it amounts to. And as soon as you finish ground school, I'll be around and prove it to you on the trainer. How about it?